The spanning tree protocol. We started this in the previous class, but I'm going to repeat once again. Then we'll get into deep dive of STP. The reason why we need this protocol is to prevent layer 2 loops. Layer 2 loops. Yeah. So why in first place loop occurs in STP in layer 2? Why loop occurs? Let's take an example. You see, we have a computer which depends on DHCP for an IP address. DHCP client. What do the client do to get an IP address? Can anyone explain? What do client do to get an IP address from a DHCP server? Have we learned DHCP or not? The DORA, discover, offer, yes or no? Okay, then tell me. Yeah, we call it as what? Client will send a discover packet. The packet itself is known as discover. Discover, offer, request, and acknowledgement. This is what together we call it as DORA. 4 packets. Now, you see, if the client sends a discover packet, which is a layer 2 broadcast, because it's a broadcast packet, switch must send the packet via all the ports to which this is connected. You see, on receiving a broadcast packet, switch is going to send it to all the ports, including this port. Now, when this packet hits the second switch, where the server is, the DHCP server, when the packet goes to server, server responds with offer, and then again client sends the request and then acknowledgement. So this is how server client relationship is. Now, what if this administrator connects another wire? Why he is connecting another wire in first place? For high availability, for redundancy. He connected this orange wire thinking that if in my absence the link fails, there will be still connectivity. No one will complain. It's a good idea. Having a redundant path is a good idea. That's correct. But the problem is this. When a client sends a broadcast, that broadcast will be sent via all the ports. The one which is hitting on this port will be coming back here. Again, it will take a U-turn and go back. Not only that, go to everyone. And this packet which is going in this direction, when it hits, it's take a U-turn. It is not only taking U-turn, it's going everywhere. And then again taking a U-turn, going everywhere. So you can see a bidirectional loop. And after some time, if you see, the same packet will be here, 100 packets in one direction, another 100 in another direction, consuming the whole bandwidth. See, whenever we got a redundant path, this is the problem. We will end up in loop. Redundant path is good so that when the primary path goes down, we will have a backup path. If this is the primary path, and when you got a redundant path, you are carefree. When this goes down, you can still sleep at home. No one is going to call you because the traffic is going to go like this. So you may have 300 employees connected here, 300 employees connected here. All 600 are able to communicate even when this link goes down because you got a backup path. But at the same time, loop occurs. If loop is avoided, then you are really enjoying your sleep. Even when the link goes down, there is another backup path, and that is also a loop-free path. A very good advantage, you see, having a redundant path without loop. So you have to somehow avoid loop. Redundant path is good, but the loop is not good. To prevent the loop, we have STP. So now you can very well have a redundant path. No problem about loops. You don't need to worry about loop. Redundant path is good. A loop-free redundant path is good. And loop-free is guaranteed by STP, spanning tree protocol. See, not only DHCP is doing layer 2 broadcast. Even if a packet goes to a switch for which the destination is unknown, if the destination is unknown, what switch will do? It will flood. Even ARP will do layer 2 broadcast, isn't it? ARP, DHCP, all this will do layer 2 broadcast, which will cause loop if no STP. When you got redundant paths with no STP, then only loop. So STP is very mandatory one. STP is very important to prevent loop. STP is very important. In a very big airports, you see, there will be runways. One aeroplane will be parked here. Another aeroplane is parked here. Another aeroplane is parked here. And now, like this, hundreds of aeroplanes will be there. In Dubai airport, if you go, Emirates airport, hundreds will be there in one row. 100 aeroplanes will be there. So now, if this guy needs to take this runway to take off to India, this flight will come in reverse. Flight won't come in reverse. Actually, there will be one vehicle pulling the flight, actually not pulling, pushing the flight to the track here. So flight will come and it will start moving this direction. And it goes to the end and takes a U-turn. So by the time the flight comes here, the pilot himself will not know whether he is in this road or he is in this road or in this road. That big it will be. So to prevent pilot going back to this road, what they will do, they will have a block. They will have a block. Not allowed to enter. Not allowed to. It's only for leaving. You cannot enter. Enter is not allowed. So if the pilot goes here and tries to take a right, thinking he is going to the actual runway is here, he will never get confused because the right is not allowed. and he knows that I need to proceed. You see, the chief minister, sorry, the prime minister is coming to Tamil Nadu, to that great city Tiruchi, where our Priya is, in 2 days. That type of big airports will have this type of arrangements. To prevent loop, the flight will not be allowed to enter in this road, so loop won't occur. If this is not there, sometime accidentally, pilot will think that he is taking this turn. Actually, he is turning here. He will think he is taking this turn, and he will be going back to the same route. That will end up in accident. See, so this block is very good to prevent loop. Likewise, this block here is good to prevent loop. Now, we are going to see how STP, how the spanning tree protocol finds a port to block. See, it will not randomly block one port. There is a logic behind selecting the spot to to block. There is a procedure. There is a step involved in finding a blocking spot, a port to block. That is what we are going to learn now. See, in switching topic, you won't have much lab to do. A lot of stories to know, that's all. See, this STP, spanning tree, you are not going to enable. They are enabled by default. They are enabled by default. Yeah, jolly. We are going to only listen to story, no labs. Appa. Is that your feeling? Then why are we learning, to tune this STP so that if you don't like that default blocking spot, if you have another place to block, you will know where to tune. That's why we are learning. Why are we learning? So that you will understand how STP finds a blocking port. And if you want to override that and choose another blocking port, you will know what to tell this STP to pick another blocking port. That's why we are learning. Okay. Now, let us call this as switch 1 and this is switch 2. And I will call this port as F01 and this port as F011 and this port as F022 and this port as F02. Say I'm randomly writing some numbers, okay? Now, between these two switches, not only between these two switches, from every port on the switch, there is a teeny packet. What packet? A small packet called Bridge Protocol Data Unit. Bridge. In olden days, switch is called as bridge. Bridge Protocol Data Unit. Bridge Protocol Data Unit, BPDU. This tiny packet carries the information of one switch to the other. Carries the information of switch and the port from where it is coming out to the other switch. So by receiving a BPDU from switch 1, switch 2 will know from which port of switch 1 this is coming, and how is the switch 1 identified, what MAC address the switch 1 belong to, what priority the switch 1 has got, and etc. things. You see, by default, every switch has got a priority called 3, 2, 7, 6, 8. Every switch has got a default priority called 3, 2, 7, 6, 8. That's the priority by default. Every switch will have this priority 3, 2, 7, 6, 8. Yeah. Now these informations are shared to one another by a packet called BPDU. So switch 2 knows the priority of switch 1, not only the priority, the MAC address of switch 1. Let us take MAC address of switch 1 as AAA, just for an example. This is what? MAC address. And here for B, the MAC address is, let me call it as BBB. Okay, this is just an example. What is the size of MAC address? 48 bits. Now, switch 2 knows the MAC address of switch 1, priority of switch 1, and if BPD is coming from this port, switch 2 will know that I am receiving this BPD from this port. All these infos are carried in that packet called BPD. Not only that, these links, they have some cost. We call it as spanning tree cost, STP cost. STP cost for 100 meg, 100 meg. What is 100 meg? 100 megabit per second. Fast Ethernets are 100 meg wire. Remember this. Fast Ethernet cables are 100 meg cables. Gig Ethernet cables are 1000 meg. Simply Ethernet, it is only 10 meg. This represents what? Speed. Okay, speed. So if the speed is 100 meg, the default spanning tree cost is 19. So all these infos will be shared between these two switches with the help of this packet called BPDU. So you need to understand one thing. Where are we heading? We are trying to understand how a blocking spot is decided. How a blocking spot is decided. That is what we are trying to understand. How a STP finds one blocking spot. For that, this is very important information. Whatever BPDU brings, it's very important for STP to decide. As I said, STP will not randomly pick one port for blocking. It depends on some datas, inputs. Those datas, those inputs are learned from this packet called BPDU. Don't forget this. The very important building block of spanning tree is BPDU. Without BPDU, spanning tree cannot function. Without BPDU, spanning tree cannot function. BPDs are very important. So based on the BPDU inputs, spanning tree will start finding one nice port for blocking so that the loop can be avoided. Okay, now what does spanning tree first look into to pick one switch as the switch of this LAN segment? I repeat, one of the switch, will be elected as a root switch. What switch? Root switch. Here I have drawn only two switches. You may have 5 switches, you may have 4 switches, or you may have more than that. We'll talk about those more number of switches in the next class. Let us first try understanding only with 2 switches. More bigger, more complicated, right? So let's try to first understand with 2 switches. Between these 2 switches, one switch will be elected as the root switch. What is the root switch? The root switch is the captain of the ship. What does that mean? The commander in chief. What does that mean? The dictator. What does that mean? That is the one which is going to decide who is who. That is the one which is going to decide who will do what. Yeah. One of the switch will be elected as the root switch. Based on what? The MAC address. MAC address. MAC address. STP, this S stands for spanning, right? Spanning tree. I also want to take SS small. Yes. S for spanning, S for small. Why I am saying this? Yes, it will compare the MAC address. Whichever the MAC address is smaller, spanning tree like small. Okay, so spanning tree will compare the MAC address. These 2 switches are sharing their BPDU. In their BPDU, MAC address is present. So switch 1 compares its own MAC address with MAC address of switch 2. So now switch 1 says, I am the root switch because my MAC address is a smaller than BPP. So this is becoming what? Root. Root switch. You see, root is very important for a plant. If we have roots, you might have drawn in biology, in botany, better than me, a taproot. There are different types of root. I think taproot will be like this only. I still remember. So it is more than, how many years? 17, 18, 19, 20, 21, 22 years back, 23 years back. 24 years back, I think, almost 25 years, take it. When I was in 10th only, I draw this. Taproots. You see, you cannot block this. If you block this one root, maybe one branch on the top will get dry because every root is important here. What I'm trying to say is there is no blocking port on the root switch. If a switch is elected as a root switch, then there is no blocking on that switch. This port will never block. This is a forwarding port. We call it as designated forwarding. It's a designated forwarding port. On the root On the root switch, all the ports are designated to forward. They are designated means they're appointed not to block. That's the meaning, not to block. They are designated to forward. They're appointed to forward traffic because it's a member of a route. It's a member of a route. Okay, so we have understood that it is already 50-50 gone. Out of 4 ports, already 2 ports we have we have removed from the discussion of blocking. Definitely those 2 ports are not going to block. So blocking may occur on F011 of switch 2. This is 11. Or F02. Blocking should happen either here or there. Either here or here. Now let's see how it elects between these two, a blocking port. Now what the switch 2 will do? Switch 2 will now find the low cost path to reach the root switch. Switch 2 will try to find the low cost path. Is this path lower in cost to reach the root switch, or this path is lower? Unfortunately, in our case, both the cost is same. If in case I have gig Ethernet, let's say I have gig Ethernet, then the cost is going to be 4. Okay, now let me write down here. For fast Ethernet 100 meg, cost is 19. For gig Ethernet 1000 meg, cost is 4. For Ethernet 10 meg, cost is 100. Okay, now gig Ethernet is what this cable is, and this cable is fast Ethernet. So what this switch will do, switch 2 will do, switch 2 will prefer this path, and it will call this port as root port. What is root port? A port that takes you to the root switch. This is a root switch. This is the port that takes you to the root switch. If this is root port, then this has to block. You see how the blocking port is selected. Low cost path is going to be root port, and the other one will be blocking. But let us take the original scenario. Cost is same. If the cost is same, what is the procedure? If there is a tie-in cost, this is all called as STP cost. Here we have both the links fast Ethernet, and there is a tie in the cost. And now what it will compare is the incoming port priority. What did I say? Incoming. Most of the people will leave this word incoming. They ignore this word. They simply take port priority. No, not simply port priority. It is incoming. Say for example, if this is 11, the port priority will be 128.11. What is this priority? 128.2. So they will see, they will leave this word incoming. They will only see port priority, and they will say, hey, spanning tree like small, and this is small, and this will be root port. And this will block. That is what they will think. Who will think? Those who ignore this word incoming will take port priority as the word, and they will say, see, this port priority is lower than this. So this lower one will be a root port, because spanning tree will it like small priority, small MAC address. Because there is a tie in the priority, it was choosing the small MAC address. Likewise, when there is a tie in the cost, it chooses the small port priority. Now, that's not the story. The actual story is incoming. The word incoming is very important. You see, here what is the priority? 128.1. That is what incoming to F011. What is incoming on F02? 128.22. Now, which one is lower? 128.11 that is coming in this port is lower than 120.22 that comes in this port. Lower is better, right? Small is better. So this will be the root port. And this will be the blocking port. Understand very well here. If it compares the local port priority, then your answer will be this will be the root port. No, that's not the way it works. Incoming. What is coming priority from the top? In that, which one is lower? And where it is received? It is received on F011. 128.1 is the lowest one. 120.1 or 120.22, which one is lower? 120.1 is lower. Where it is received? It is received on F011. So that port F011 is the root port. The other one is a blocking port. So this is the procedure for finding the blocking port. I'm going to tell again. After that, I'll ask question. But this time I will be asking question in the middle. The name of the switch is switch 1. This is switch 2. And I'm taking a cable more than one for redundancy. And STP need to find one blocking port to prevent loop. Now let me write down a number F0/5, F0/15, F0/2, F0/10. Now the priority on this one is 32768. The priority on this one is 32768. The MAC address of this one is 1111. This one is 2222. Listen carefully. In order to select a root switch, what switch? Root switch. The priority is compared first. First, it will compare only the priority. If there is one switch with a lower priority, that will become a root switch. But by default, all the switches will have 32768. Now you understand why we are learning spanning tree. If I want one of the switch to be a root switch, I can go and change the priority lower than this 32768. Now let us try to understand first the default. Because the priority is same, it compares the MAC address and makes switch 1 as the root switch. You know why, Priya? Why switch 1 will become a root switch? Great. Smaller MAC address. If the priority is same, then it will check the then it will check the MAC address, compare the MAC address. The switch whose MAC address is smaller becomes the root switch. So switch 1 becomes the root switch. What is special in a root switch? Anyone answer? What is special in root switch? Anyone can answer? Correct. That's the special of root switch. The ports of the root switch will not block. They will only forward. We call it as designated to forwarding. Okay. So what is next? Next is this non-root switch, non-root switch should elect one root port and block the other. And block the other. Okay. For that, what it will do? It will compare the cost. What is the cost for 100 meg speed wire? What is the STP cost for 100 meg wire? What is the default? 19. That is the default cost. Right. Because the cost is same, it will now compare the port priority. But if one cost is lower than the other, for example, if the cost is here 4, then tell me which one would have been the root port and which one would have blocked. Correct. This G02 would have become root port. Why it is called as root port? Because it is talking to the root switch. See, the root portங்கிறது root switchல வராது. root portங்கிற word வந்து non-root switchல தான் இருக்கும். Non-root switch root switchோட தொடர்பு கொள்ள பயன்படுத்தப்படும் அந்த போர்ட்டுக்கு தான் root port என்று பெயர். And as you said, Pavitra, this is going to block. Okay, now our cases both have same speed, so same cost. In this case, port priority. The port priority of this port is 128.5, 128.10, 128.2, 128.15. So now switch 2 will compare the incoming port priority. What is incoming here? 128.5 is incoming. What is coming inside to F02? 120.10. Which one is smaller? 128.5 is smaller. So this is receiving the small one. So this is called as root port. And this will block. Why this is blocking? Even though the local priority is lower, but the incoming is what it focuses on. Did you understand this point? Incoming matter, very important. So you all have understood very well. Now let us go to the command line. Sorry, let us go to the lab and check whether what we have learned is true or false. When you type show spanning tree, don't see this number, this MAC address. The MAC address under the bridge ID is the MAC address of this particular switch which you are in. I copy this MAC address and I put it here for your reference. I also want to show you The default priority is 32768. You see, 32768 priority. Okay, so that's the default priority. Now, I would like to copy the MAC address of this switch. Show spanning tree. Copy the MAC address which is under this bridge. Paste it. Okay, as I told you, the priority is same on both the switches. So I copy this and put it on this switch also in by this one. Right. Now, let us first discuss the board, then we will come and verify whether what we have understood is correct or not. You see, first it will check the priority, same priority. Now it will compare the MAC address. Which one has got lower MAC address? Switch 1 or switch 2? அப்படியே பாருங்க, first number பாருங்க, இங்கேயும் 0, இங்கேயும் 0. சரி, second number இங்கேயும் 0, இங்க third number இங்க 0 இருக்கு, இங்க 5 இருக்கு. Which one is smaller then? Switch 1's MAC address is smaller. So this will become a root port. What does that mean? These two ports are designated to forward. Am I right? We are going to check these things now. Root switch. Thank you. Root switch. Very correct. And I'm very sorry. I'm wrong. Root switch. That's the right word. Not root port. Okay. So these three things we will go and check on the switch. Are you ready? I'll take it to switch 1. And I'll show you. You see, this says this bridge is the root. And you see, both the ports are designated to forward. Both the ports are designated to forward. And you see, I told you the cost, 1919. And I told you the port priority, you see. F01 has got .1. F024 has got .24, 128.24. All right, now let me also write down that 128.24, 128.1. Okay. Now this part is over. Let's focus on this part. Because the cost is 19 and 19, there is a tie. Which one will be blocking? Which one will be forwarding? Will F01 block or F024 block? F01 will be blocking. Why? Because the incoming is greater. On F01, incoming is bigger, 128.24, whereas here the incoming is 128.1. So F024 should be what? Am I right or not? Yeah, of course, no. If F01 is blocking, F024 should be what? Root port. Am I correct or not? Let's go verify that. I'll go to switch 2 and say, look at this. F01 is blocking. Where is it? F01 should be blocking. Yes, it is blocking. We wrote it correct. F024 should be root port. F024 is a root port forwarding. You understood now how STP finds a blocking port? Okay.